Question 3, solve each quadratic equation with the method of your choice. So right now, we can either use square roots, we can use factoring, or we can use completing the square. So I'm just going to look at each one of these and determine which way I want to solve it. So with this one here, I have a quadratic and a linear term. So this one is probably going to either be factoring or complete the square. Okay, for this one, I have an x squared and a linear. So again, I'm either going to do factoring or completing the square. This one, I only have the quadratic term, so I'm probably going to use the square root for this one. I don't have a linear term. This one, I have the quadratic term and a linear term, but the coefficient here is greater than 1, so I'm going to try factoring this one because I don't know how to do completing the square when the coefficient here is greater than 1. And again, same thing with this one. I have a coefficient that's greater than 1 on my quadratic, and I have a quadratic and a linear term, so I will probably do factoring for this one as well. So let's start off with this expression up here. The first thing I want to do if it's a quadratic is I want to move this over. If I'm not doing completing the square, I want this expression to be equal to 0. So if we have x squared minus 2x is equal to negative 1, I want to add 1 to both sides. So I'm going to put that in between here and here. So x squared minus 2x plus 1 is equal to 0. Now if I'm going to factor this, I want to find two numbers that multiply to positive 1 and also subtract to negative 2. So I'm going to try x minus 1 and x minus 1 equals 0. So negative 1x and negative 1x is negative 2x, and negative 1 times negative 1 is positive 1. So my two solutions would be x is equal to 1 and x is equal to 1. So you can put it twice, but since they're repeat solutions, you really only need to write it one time. Okay, on the second one, again, if we're not going to use completing the square, we want all of our terms to be on one side of the equation. If we are going to use completing the square, we want there to be a little blank here because we want this to be a perfect square trinomial. So I'm going to take this, we're going to do completing the square on this one. So we're going to start off, we have x squared plus 8x plus 14 is equal to 23. So the first thing we're going to do is we're going to move this 14 to the other side because we want a space so that we can make this into a perfect square trinomial. So we need to figure out what c is going to be here, what our new constant is. And whatever we add to one side of the equation, remember we have to add to the other side. So if we have x squared plus 8x plus something over here, that same something has to get added to this side. So the way that we figure out the number that goes here, c, is we take this number, we cut this in half, which is 4, and then we square that, which is 16. So we're going to add 16 to both sides. And on this side, we're going to do x plus 4 squared is equal to 25. So in order to undo squaring this, we're going to take the square root, and when we take the square root, we know that we have to do the positive and the negative version. So we get x plus 4 is equal to the positive and negative 5, because the square root of 25 is 5. So when we subtract 4 from both sides, this plus or minus sign right here is telling us that we're going to have two answers. So one of those answers we're going to get by doing negative 4 plus 5, which is equal to 1. And the other answer we're going to get by doing negative 4 minus 5. So that's what this means. This means we have two different answers, negative 4 plus 5, negative 4 minus 5. And so we have two different answers, which are x equals 1 and x equals negative 9. For this one right here, we're going to use square roots. So if you only have the quadratic term, what you can do is you can set these two on opposite sides of each other. So x squared is equal to 15. Remember, we're adding 15 to both sides. So these two eliminate each other. 0 plus 15 is 15. And so we just take the square root on both sides. And remember, when we take the square root, we need to do the positive and negative version. So x would be equal to positive square root of 15 and negative square root of 15. So when we write those in the answer up here, we would do x is equal to the square root of 15 and x is equal to the negative square root of 15. Okay, on these two down here, I'm going to try and use factoring for them. So on the 7x squared minus 2x minus 5, we're going to start off by putting the first term and the last term in the top left and bottom right. So we've got 7x squared times 5, negative 5. So when we multiply on the diagonal, we get negative 35x squared. And so we're looking for two numbers that multiply to negative 35, but also add to negative 2. So that would be negative 7x and positive 5x. So the GCF for these two here would be 7x, and then I need another x up here, I need 1 over here, and then I need a 5 down here. So we would have 7x plus 5 is equal to 0. Remember, the zeros come from the factors. And then we would also have x minus 1 is equal to 0. So x is going to be equal to 1, and x is going to be equal to negative 5 over 7, because you're going to subtract 5, which is where you get the negative 5, and then you're going to divide by 7, which is where you get this. So x is equal to 1, and x is equal to negative 5/7. All right, for the last one, I'm going to erase some of this here so that I've got a little bit more space to write. We're going to use factoring again. But the one thing that we have to be careful of when we factor is that we need to factor out any GCFs first. So first thing we're going to do is we're going to move everything all over to one side, because the only time that we want something on the other side is when we're completing the square. Any other time we want everything all on the same side. So 2x squared plus 12x minus 8, so that's how we move this over. We're going to subtract 8 from both sides, is equal to 0. So I see that everything here is divisible by 2, so I'm going to factor out a 2 from everything. So 2 times x squared plus 6x minus 4 is equal to 0. And I'm not sure that this one can be factored. So we're just going to leave this one off, because this one would need to be done using the quadratic formula, and we haven't necessarily gone over that one yet. So we're going to leave that one off for now.